Hi mates, today we'll be discussing about Maxwell's law of equipartition of energy, and we'll derive from Maxwell's law of equipartition of energy till delta U is equal to nCv delta T in thermodynamics, of course. So without taking much time, I'll explain you how it is done. I'll write Maxwell's law of equipartition of energy from here till delta U is equal to nCv delta T, right? अब आते हैं मैक्सवेल क्या कहता है. मैक्सवेल सेज कि द काइनेटिक एनर्जी ऑफ 1 डिग्री ऑफ फ्रीडम इज इक्वल टू हाफ के टी. सो इफ आई राइट द काइनेटिक एनर्जी फॉर 1 डिग्री ऑफ फ्रीडम इज 1/2 k into t, right? And what is k here? So k is nothing but it is called Boltzmann constant, Boltzmann T constant, which is equal to nothing but ratio between the gas constant and Avogadro number. So this is our Boltzmann's constant. Okay, so this is about 1 degree of freedom. But how can you define 1 degree of freedom? A single monoatomic molecule has 3 degree of freedom at least. And there are several degree of freedoms depending upon whether or not the gas is monoatomic, diatomic, polyatomic, linear, non-linear. So let the degree of freedom be F in this case, because the degree of freedom or the information about gases or the molecule will be provided in the question itself. So I'll write kinetic energy for F degree of freedom. It's nothing but half kT into F, where F is degree of freedom, right? So it is for one molecule, right? What about, I'll ask you to give me the kinetic energy for 1 mole molecules, right? Let's see how it goes. Ke for 1 mole, right? It becomes half kT into F for F number of degree of freedoms into Na. Very simple. It's small concept, nothing else. See, for 1 degree of freedom, it's half kT. For F number of degree of freedom, it becomes half kT into F. Kinetic energy for 1 mole of gas will become half kT F into Na, right? But will we ever study or will we ever solve question regarding 1 mole? Maybe, maybe not. So so let's extend this concept and make it n number of moles, right? Ke into n moles. Half kT F into Na, then multiply this to n number of moles, right? Very simple unitary methods. Okay, so write it. Finally, we'll write it Ke is equal to kT F Na into n. Okay, now the twist comes. We know the value of K here. K can be substituted with, if I'll show you here, we can substitute K with R by Na. Let's see what happens. We can write R by Na Tf Na into n. Don't get confused into capital N and small n. This is just for the sake of derivation. I'll write it properly when the derivation is done. I know this is very unprofessional way to do it. Can you please forgive me for that, because I'm still learning. So we can write R upon, this is Avogadro number, into T into degree of freedom F into again Na, which is Avogadro number, into number of moles, which is n. We can see n to n gets cancelled and all we are left with is RT F into n. And one thing is missing here. Here we had 2 hidden here, right? You can see here ये half वाला 2, and since everything is multiplied together, so एक लंबी सी लाइन खींच के we can write 2 सबके नीचे. यहाँ भी 2 was missing, and यहाँ भी 2 was missing, and यहाँ भी 2 was missing, right? So we can rearrange it like n into n is number of moles, जो कि हमेशा पहले लिखते हैं, then F, then R is gas constant, then T is temperature, upon 2, nafrat by 2 we call it, just for the sake of remembering it, like mnemonics or whatever. So this is nafrat by 2, and this is kinetic energy, of course. Kinetic energy is equal to नफरत by 2, right? So यहाँ पे one more important derivation comes in play, which is total energy. Let's write total energy as U is equal to, obviously we have all studied earlier, kinetic energy plus potential energy, right? We assume that gases have no potential energy for the time being. It may have, it may not have, but since it's not in our syllabus, so we'll assume it as 0. So total energy is equal to kinetic energy. We can also say total energy because of kinetic energy, or total energy of the gas is because of kinetic energy, right? So now total energy becomes NFRT by 2, right? Now we have to change this total energy. We have to convert this U into delta U. So what if I write U1, like for same gas, what is that quantity that we can change? Here we have like number of moles, which is not changeable. Degree of freedom cannot be changed. Gas constant, as the name suggests, it's a constant in itself, so it cannot be changed. So these three are constant. Only temperature can be changed. So we can write NFRT1 for U1. So from U to U1 it becomes NFRT1 by 2, and for U2 it becomes NFRT2 by 2, right? So we'll write delta U, which is U2 minus U1, becomes NFRT2 minus T1. कहाँ से? U2 minus U1 is delta U, so T2 minus T1 is delta T. NFR delta T, and by 2 तो पहले से था ही, right? Again, when we write NFR by 2 into delta T, this FR by 2 is nothing but, my friends, it is CV. So nCv delta T is equal to delta U, and एक और बात पता चली, that CV is equal to FR by 2, right? Okay, so let me recapitulate it really quick for you. So Maxwell's law of equipartition of energy says kinetic energy for 1 degree of freedom is half kT. A molecule will never have 1 degree of freedom. It will at least have 3 degree of freedom for monoatomic molecule, 6 for polyatomic molecule, depending upon whether or not the molecule is linear or non-linear, right? Since kinetic energy of 1 degree of freedom is half kT, so for F degree of freedom, the kinetic energy will become half kT into F simply. And now for 1 mole of molecules, it will become half kTF into Na. But since we will not study only 1 mole, so let's assume the number of mole to be n moles, right? So for n moles, the degree of freedom will become half kTF Na into n. It is extending. Now we can substitute K with R by Na. While doing so, we can see that Na and Na gets cancelled, and it becomes NFRT by 2. Kinetic energy, this is again for n number of moles for F degree of freedom. And then we studied that kinetic energy is also internal energy of the gas, because we are assuming that potential energy is 0. So kinetic energy becomes internal energy, right? So we can write internal energy is equal to NFRT by 2. And if we want to change the internal energy of the same set of gases, like for example, we have a monoatomic gas, what can we change? We cannot change the number of moles for the gas. We cannot obviously not change the degree of freedom, because it will anyways be 3 in this case, in the case of monoatomic gas, right? And for gas, constant is constant in itself, and all we can change is temperature. So we'll change temperature. For U1 we'll take temperature T1, for U2 we'll take temperature T2. So the first equation becomes U1 is equal to NFRT 1 by 2, and the second equation becomes U2 is equal to NFRT 2 by 2, right? So U2 minus U1 is delta U. Similarly, T2 minus T1 is delta T. So delta U is equal to NFR delta T by 2, where FR by 2 is our CV. So delta U is equal to nCv delta T, and hence proved. from Maxwell's law of equipartition of energy till delta U is equal to nCv delta T. This was our suffer. Thanks for watching and subscribe कर दो यार, कर दिया करो, ठीक है? Thank you.